Hey math enthusiast, I'm here to go over the notes for the next section, 6.1, which deals with ratios, proportions, and geometric mean. First thing we need to know is exactly what a ratio is. It's just a comparison of two different numbers. All right, it can be represented a couple different ways, A to B, A with a colon in between and B, or kind of like a fraction like A slash B. Now, as I said, it's just a comparison of two numbers. So one example might be the score in a football game, 27 to 23. Another example might be the downs, second down and 10, comparing the number of downs and the amount of yardage to go. The other thing you need to know about ratios is that you always want them in the simplest form. All right, it's also a matter of what those units are. You want them to be in the same units. So let's take a look at this first one. They're telling me my ratio is 7 quarts to 550 gallons. Well, the first problem is they're not in the same units. So I either want to change them both to quarts or both to gallons. The rule of thumb for this is always go with the smaller unit. All right, quarts is smaller than gallons, so my goal is to change both of these to quarts. I'm just going to write it down here. So I'm going to do 7 quarts, but then the problem is I need to change that 550 gallons into quarts. Well, first thing you need to know is 1 gallon is equal to how many quarts? Well, 1 gallon is going to be equal to 4 quarts, so now I got to deal with 550. So 500, and I'll just write it over here, 550 gallons is going to be 2,200 quarts. So for my ratio, now I'm going to change this from 7 quarts to 550 gallons to 7 quarts to 2,200 quarts. Now they're both in the same units, and in this case I can't simplify it, so I'm actually just going to leave it like that. So for this next example, now I'm dealing with inches and feet. I want to go with the smaller units. So I want to change both of them into inches. So I'm still going to have 10 inches. And I'm going to change the 2 feet. Well, there's 12 inches in 1 foot. So there's going to be 24 inches in 2 feet. Last thing I want to do is just try to reduce this. It looks like I can divide them both by 2. Which is going to leave me with 5 inches to, this will work, 5 inches to 12 inches. Next one, we got days and hours. I want to change them both to hours. So I'm going to keep this as 80 hours. And then there's 24 hours in 1 day, so there's 48 hours in 2. Last thing I want to do is just try to reduce this. Looks like I can divide them both by 16, which is going to leave me with 5 hours and 3 hours. Last one, pounds and ounces. The smaller unit is going to be ounces, so I'm going to keep the top as 10 ounces, and in 1 pound, there's 16 ounces. So in 3 pounds, there's going to be 48 ounces. So now I just want to reduce this. Looks like I can divide them both by 2, which is going to give me 5 ounces over 24 ounces. The next problem introduces an extended ratio. So instead of comparing 2 numbers, now I moved on to comparing 3. Now, the reason I'm using the extended ratio is because I'm referring to angles in a triangle. So if I have my triangle, obviously there's going to be 3 angles that make that up, 1, 2, and 3. Okay, in this case, what they're telling me is that my extended ratio simplifies down to 1, 3, 5. So let's say, for example, maybe my angle measures are 2, 6, and 10. So in this case, I've just doubled all of them. Okay, well, the thing is, I know the angle measures in a triangle have to add up to 180. Okay, well, 2, 6, and 10 do not add up to 180. So what if I did like 3, 9, and 15? Okay, that does not add up to 180. All right, but essentially what I'm looking for is to try to figure out what am I multiplying this by so that all three angles together are going to equal 180. So essentially I'm trying to solve for x. So I want to set it equal to 180, and according to my ratio it's going to be 1x, 1 times the value, plus 3x, 3 times the value, plus 5x, 5 times the value. So once again, when my ratio is simplified, it's going to be 1, 3, 5. Okay, but I got to figure out what it was originally before it was simplified. So when I add these up, obviously I'm going to get 9x equals 180. So it looks like x is going to equal 20. Well, if x equals 20, that means my original ratio before it was simplified was going to be 20, 60, and 100. These three together, they do add up to 180. And obviously, if I'm simplifying, it's going to bring me back to this extended ratio 1, 3, 5. Next problem, now I'm dealing with the area of a rectangular room. So I know that my total area is 180 square feet. And they're telling me the ratio of width to length. So width to length is 5 to 4. So in other words, if my width here is, let's say, 5, and my length is 4, okay, that should give me my area. But the problem is my area is equal to 180. All right, and I know the formula for area is length times width. Well, if I do 4 times 5, that's only going to give me 20. I got to figure out, okay, well, what was it originally before I reduced it down to 4 or 5? So it's similar to the last problem. Okay, I essentially got to figure out what did I multiply these values by before I reduce them down to get this basic ratio 5, 4. So instead of length and width here, I'm going to replace them, and I'm going to write it over on the left-hand side. We're going to say 5x for my length and 4x for my width, and together they're going to equal 180. So I'm solving for this x. What was it originally before it was reduced to 5/4? So when I multiply these together, 5 and 4 is going to give me 20. X and x is going to give me x squared, remember, and it's equal to 180. Oh. Equal to 180. So first thing I'm going to do is just get rid of that 20. So I'm going to end up with x squared equals 9. So it looks like in this case x is equal to 3. So if I go back to my original problem, now I'm saying, all right, if x is 3, that means my side lengths originally were 12 and 15. And if I multiply those two together, 12 and 15, I do get 180. Now this next problem is very similar to the previous one. I'm given the perimeter of my rectangle. So let's say, for example, here's my rectangle. I know the perimeter is 280. So all the way around is 280. And the ratio of width to length, so width to length is 11 to 9. So let's say, for example, my width is 11 and my length is 9. But the problem is if I add all those up, that's not going to get me 280. So once again, I'm trying to figure out what was it originally before it was reduced down to 11 and 9? So for example, maybe it was 22 and 18. But does that add up to 280 if I put that in for my width and my length? I don't think so. So remember, you're looking for that x value. What were these multiplied by before they were reduced? So first off, my perimeter is 280. And you got to remember the formula for perimeter is 2 times the length plus 2 times the width. And as I said, it equals 280. Now, instead of length and width, all right, they give me my numbers up here, 11 and 9. So this is going to be my width, 11x, and 9x is going to be my length. So now I'm going to have 2 times 9x and 2 times 11x equals 280. So after I multiply, I'm going to end up with 18x and 22x. Together, that's going to give me 40x, which equals 280. Next thing, I want to divide by 40, so x is going to equal 7. So then that tells me that my dimensions for my rectangle were actually 77 and 63. Now the next part of my notes deals with proportions. So moving from ratios to proportions, a proportion is just when you set two ratios equal to one another. So for example, you might have like x over 2 equals 5 over 10. All right. After that, they do have specific terms for where these values are placed. So they have the means and the extremes. And you can see in this picture, the extremes are the first and the last terms you write down, while the means are the terms in the middle. All right, and that's going to be used for our definition later. Now, just to review briefly, as far as solving proportions, like the one we had, so if I say like x over 10 equals 1 over 2, for example. To solve this, you guys, I think, already know what I have to do is cross multiply, or what they call the cross products property. So I'm going to multiply my two extremes, my two means, which tells me that x equals 5. So I know in order to solve these proportions, I'm just going to cross multiply. So I'm going to have 19 times 15x minus 11. And then on the other side, I'm going to have 32 times 7x plus 3. Now I just need to distribute through. So 19 times both those terms, 32 times both of these, which gives me 285x minus 209 equals 224x plus 96. So we'll get all our x's together, which is going to give me 61x. Over on the other side, we're going to have 305. After I divide by 61, looks like x equals 5. Now, for 9 and 10, it's going to be the same setup. You're just going to have to go through and cross multiply. All right, just remember, use parentheses around these terms so that you distribute through both of them. And remember that x times x is going to give you x squared. I'm not going to go through all the work for 9 and 10, but for number 9, x should equal 12. And for number 10, x equals 16. For the next couple problems, this is the information they start you with. So they're telling you that RS over RT is going to be equal to 13 over 25. So I essentially set up this proportion with all the information that I'm given. But instead of writing RS and RT, what I'm going to fill in there are the lengths that they actually give me. So they tell me RS is 104, and they tell me RT down here is 18Z minus 16. So now I'm just going to go through and cross multiply like I did with the other problems. So I'm going to have 104 times 25. And on the other side, I'm going to have 13 times this whole expression, 18Z minus 16. So I have 2600, and then I have 234Z minus 208. So now I'm going to get that 234Z all by itself. I'm going to move the 208 over here, which gives me 2,808, and lastly divide by 234, which tells me that Z equals 12. So for number 12, start off the same way. So with the given information, they tell me that AB to AC is going to reduce down to or is equal to 8 to 5. Well, then just replace the values that you have. So let's get rid of AB and AC, and let's fill in what they actually give me. So they tell me AB is this side 60, and AC is this side 3D plus 2. Cross multiply and solve. So for this next problem, let's focus on everything we're given. So they're talking about a widescreen TV, and the aspect ratio is 16 to 9. So that's comparing the width to the height. So let's start with that. So they're telling me my width to height ratio is going to be equal to 16 to 9. Now I know the units they're talking about are inches in this case. And what they're telling me right here is that the width is actually 26 inches. So just like what I did for the last problem, is in my ratio, I'm going to replace that width with 26 now. Okay, and what they're asking for is the height. So this is what I'm solving for h. So let's go through, cross multiply, and we'll solve for h. So I end up with 26 times 9. On the other side, I have 16 times h. So I have 234 equals 16h, and when I divide by 16, I'm not going to get a whole number, but it looks like my height is going to come out to be 14.625, and I know I'm dealing in inches. Now the last part of our notes deals with geometric mean. So for geometric mean, I'm dealing with two values, a and b, and I'm looking for the x, which is considered the geometric mean. Now in this case, I would have a ratio set up like this. So here's my a and b, and then my x's are always going to be across from one another like this. Now when I have a proportion set up like this, that means when I cross multiply, I'm always going to end up with, sorry, that should be x squared, and it's always going to be equal to a times b. Now, what's going to follow after that is that I know that x is actually going to equal the square root of a times b. So it's always going to follow these three steps for geometric mean. It's always going to be set up like this, followed by x squared equals a times b, followed by x is equal to the square root of a and b. So for this first example, they want the geometric mean for these two numbers. So here's your a, and here's your b. So if I were to set it up, as they told me for my definition, it would be 4 over x equals x over 25. Now I know when I cross multiply, I know it's going to turn into x squared equals 4 times 25, which is 100, which tells me that for this first problem, x equals 10. So my geometric mean between 4 and 25 is 10. Now for the next problem, I know it's going to be set up the same way. So if I want to, I can just jump to this second step that I had back here. So I know it's going to be x squared equal to 12 times 27, which is going to give me 324. And then the last thing I have to do is just take the square root on both sides. So for number 15, my geometric mean is actually going to be 18. Now, for this last problem, they're telling you the geometric mean is going to come out to be 12. So let's think about this. My final answer is 12. So I got to work backwards and figure out, okay, let's say I set it up to solve for my geometric mean. What were my a and b values that led me there? Well, let's think about what we did. So I would cross multiply. I would end up with x squared equals ab. Well, if x equals 12, then I know that x squared equals 144. Okay, well, then I can replace this x with 144. So now I just got to figure out a and b values that are going to equal 144. Okay, so there are multiple different answers. It says find two pairs. Well, I'm just looking for two numbers that are going to multiply to give me 144. Well, you could say 144 and 1. Or you could say 72 and 2. All right, those would both work. There are multiple different answers you can give, as long as they multiply together to give you 144.